All right, here we go. So good morning again to those of you who just arrived and to those of you out there in YouTube land. Do you guys want to say hello? Turn on mics and video. Say hello to each other and to me.
Hi.
Hi, Isabel.
Hello.
Hi, Mariana, Robert. Nice to hear a few voices and see a few faces. Okay, so a few things. First of all, I have just this minute posted the midterm part 2 stuff. So you should see over in the quiz section, you should be able to see the midterm quiz again if you weren't able to before, but you should be able to see your answers now. There's a grade for you. It's a grade out of 37. So 18.5 is a pass, and you should be able to see that. And if you go to, let me start sharing here. Okay. If you go over into the modules, there we go. And you go down to, there we are, midterm exam part 2. Right here are the sample solutions to the questions that are there. Okay, so as usual, I don't really want to go spend a lot of sort of precious class time taking it up. I give you, so what I do is instead, and I hope this is okay for most of you, is I give you the resources to take a look to see how the grade worked yourself. So you've got, if you go into the quiz, you should be able to, I hope, see my grades and also see the comments. Most questions will have a comment, unless you got full marks. If you got full marks, I may not leave a comment, but otherwise you should see one there. They can get a bit cryptic. It's not like when I have a paper test, I can circle things and write notes. So if you don't understand a comment, by all means, let me know and or send me an email or whatever, and I'll try to explain what's going on. I put deductions in the comments, so you'll see like -1, -2. The whole test should add up because it's done by a machine, but it is possible that I make a mistake in the question. So you should check that. Like if it's out of 15 and I put -2 and -1 in the comments, then you should get 12. For some of them, if your solution was really far from what I was expecting, I switch to kind of what I call a positive marking scheme, where I go through and I say, okay, they did this, that's 2 marks, and they did that, that's 1 mark, so they can get 3 marks for this question, rather than going backwards. If it's generally a good solution, I'll do deductions and mark backwards. But if it's not that great, or if there's not much there, or whatever, I'll mark forwards. In that case, you won't see any notes like with deductions. You'll probably see C solution, and then you'll have a grade, which represents me going forwards. But anyways, I fully believe in transparency of grading, which means, you guys should get to see why you got the mark you did and where it came from. So if you're not sure, after looking at, you can look at my sample solutions, you can look at your solution and my notes on it and your grade. And if you're not sure why the mark is the way that it is, or if you find an addition, you think you find an addition error, I'd be happy to take a look at it for you. Okay, so you can send me an email about that. The final exam is coming up soon. We have 1 more week of classes left, and then the final. I have now posted a module for that, which has the quick reference material that I would normally give to students in non-pandemic times. So that's just an extra little quick thing for you guys to look at. And what I've got here are some old questions. They don't necessarily cover absolutely everything we've done, but they could be useful to study from. Sessions and security, and jQuery questions and answers here from a couple of years ago. So you can use those as a study aid as well. And we will have a, excuse me, we will have a time for a review session next week. So today is going to be the end of the content. We're going to talk about security issues today. And maybe if we have time, we'll talk a little bit about jQuery. But the content is over at this point. And the final exam only explicitly covers module 5. Of course, as with every programming course, you won't really have understood module 5 if you didn't understand the previous modules. So it is kind of cumulative in that way. But the final exam is a 1-hour test. You'll have 1 hour to do it, and it only covers these topics. Now, as I've said before a number of times, but as I'm sure you guys know, there is another 2-hour period So the whole final exam period is 3 hours, and you can use that other 2-hour period if you want to write a makeup midterm that if you do well will replace parts 1 and 2 here. So it's a 2-hour midterm, potentially worth 40% if you beat your midterm 1 and 2 marks. Okay, so how to know what you need to do to figure out where you're at with the midterm is each one of them is worth 20%. So, and they're equally weighted, even though they're out of different things. So if you divide by, I think part 1 was out of 50 and part 2 was out of 37. So divide by 50 or 37, multiply by 100, that's your grade. If you average those two things together, that's your average grade on the midterm. And if you think you can beat that, it might be worth trying the makeup exam on as part of the final. But that'll be an option. You can choose to take that option in the moment or not take that option if you don't want to. Okay. The other thing is I have given everybody who handed in, unless you handed it in very recently, you should have some feedback on your final project. I do enjoy reading about the final projects and what you guys are planning on doing. I should say one thing. I made one comment and somebody kind of called me on it. I made this comment on a lot of people's projects that maybe, you know, if you have a user table and you're storing email addresses or usernames and they're going to use those to log in, and you also have an integer primary key, I think I suggested to a lot of people, maybe you should just make the username the primary key or the email the primary key, just because it'll make your lives a bit easier. Somebody called me on it not being best practice, and that's true. It is probably, and probably you guys are doing that maybe because you saw it in your database course. I don't know. But yeah, it's probably best practice to have a separate integer user ID. It'll save you space if you're using it as a foreign key. So instead of an entire email address, it'll just be one integer. It also allows the user to change their username or to change their email address. But so yeah, go for it if you want to. It just does complicate things for you for this project because then you do have to do a separate check to make sure that the user's choosing an email address or a user ID that hasn't been used before. So anyways, if they're gonna log in with that credential, then it needs to be unique. So just something to think about. If you make it the primary key, it's going to be unique. Okay. Any questions on that stuff on the final project? I should also remind you that the final hand-in date for the final project. So there's let's go to assignments here. Yeah, so your jQuery integration plan and security audit are due on Monday. Those can be quite brief. It's really just a check mark. Did you do it or not, really? I will give you some feedback on it eventually, maybe not as quickly as I did on the project plan, because that was more important. And the code is due, the due date here is not movable via late days. Okay, you can't use your late days on it. That's the final day. I need to have it in by then, or I'm just not going to get the marking done. That's the only reason. It's not for some reasons of moral character or because it's important that it come in at that time. It's the due date is where it is because they give us really tight deadlines, and there just is not enough hours in the day to grade the final exam and to grade the project if it comes in any later than that. So you can't use your late days on it. But if there's an emergency, or if you're sick, or there's something that you can't have, if there's some reason that comes up that you couldn't have foreseen, then by all means, let me know and we can negotiate a due date for you. I can do that in exceptional cases. I just can't do it for everybody. It's too dangerous. Yeah, I guess I put the due date here on the Sunday, didn't I? I think I said it was going to be the Friday, but then I put it on the Sunday, just because I don't think I'm going to mark them over the weekend. I think I'll be marking other things that weekend and preparing for other stuff. So I made it the Sunday. I should probably let the other instructors know that I did that. Yeah, you're welcome. Again, it's it's just, I want to give you guys as much time as I can. I don't want it to interfere with your final exams, which is another reason to have you, force you to kind of get it done. But mainly it's purely for giving myself enough time to grade things. Okay, any other questions about the sort of end game of the course? Okay, so this week, where are we? Back to the modules. In the what to do each week for this week, there was two videos on jQuery. And what I decided to do was leave the security discussion to today. So this lecture is going to be important for people who aren't here. They're going to need to go and read it. I did want you to read over the security material before this class, because what I would mostly like to do with this class is just spend a little bit of time giving you, working through some of the code examples that demonstrate some of the security issues, but maybe not going exhaustively over that handout. So there will be questions on the test about stuff that's in that handout, so you should make sure you familiarize yourself with it. It's a little bit longer, a little bit more wordy because of the nature of the topic. But let me ask you, how many of you watch the jQuery stuff? Just say yes or no, publicly or privately. There's 19 people here now, so that's pretty good. Most people saying yeah. Did you like it? I mean, not the videos, but do you like jQuery? Yeah, it's pretty cool. I mean, you know, how can you argue with it? If you're doing DOM manipulation, it makes your life so much easier. I tend to use it for most of my projects. It's a little bit, some people might say it's a little bit getting a little bit outdated, but I think it's a little bit early to say that. Just because there are these new frameworks out there now, React and blanking on the other one. Oh, Angular. React and Angular are the two big ones. In your 4th semester course, if you choose to take it, it's an optional course, you'll learn about the React framework. And kind of with React and those other frameworks, DOM manipulation is kind of out the window. They do the DOM manipulation in the sense that there is DOM manipulation happens behind the scenes. What you do is you define custom components that render themselves in HTML, and the React system re-renders them whenever it needs to re-render them. So it handles the DOM, and in a much better way than we can. So because of that, some people who are, and it's a beautiful system, it's really nice, but it's a little bit more cumbersome for doing projects. So when I do my personal projects, even though I usually do this thing where I debate with myself, should I use React? I really should. It would be good, but there's so much overhead to it that I usually end up defaulting to just old style DOM manipulation, and I always use jQuery, partly because it's more economical, but also because I can pretty much be guaranteed that it's going to work on every browser if I use jQuery. The browser compatibility stuff is really good. So it's great. Now I know a couple of you who had already written a bunch of raw JavaScript code for your projects are wondering what's the requirement for the project for jQuery. Just put some in there, you know. So when you're writing the integration plan, if you've already written most of your code, pick one part of it and say, I'm going to just do, you know, this particular piece of functionality. I'll do it in jQuery, so that you don't have to go and rewrite a bunch of stuff that you've already done. But if you're starting from scratch, you may want to think about doing as much as possible in jQuery, because it really is kind of a nice system. I didn't cover it, but you can also, jQuery also supports Ajax. And at this point, since Internet Explorer is still out there on some people's machines and does not support fetch, you might want to think about looking into Ajax for jQuery, jQuery for Ajax as well. But that's not officially part of the course, but you could look at that as well. Okay, so this will be the last set of videos. I guess I'll post a what to do this week for next week, but it's mostly going to be study and do your project. We'll have a review session this time next week. And like I said, we'll mostly be reviewing this stuff. So what we're going to cover, so I'm hoping that jQuery is pretty much covered. I hope you guys tried some of it. If we have some time at the end of this class, maybe we can take a look at some. But mostly what I want to look at in this class is the security stuff. So again, you have the guide. And this here is optional content. This is stuff that I took out because it was just too much. It's stuff on regular expressions, which is a powerful tool for verifying user input for things like, for for example, postal codes and phone numbers where you want them to fit a format. Regular expressions are great for that. So this is you can ignore this and the exercises that go with it. So if you ignore that, there are no exercises for this stuff. There's just a bunch of guidelines and discussion to help you understand the security issues. And what we can do now is we can go back and say all these things that I forced you to do it my way before, or a lot of them anyway, I can now, now we're going to go and explain exactly why and what's wrong with not doing it. What's wrong with the wrong way of doing it. Okay. You guys okay? Shall we do some stuff on security? Oh, I should ask you, how many of you read or at least skimmed over the guide, the 5C guide on security? A few yeses, no nos, one not yet. Okay. So this is the guide here. I'm gonna just kind of talk my way through it rather than put up slides. I really do want you guys to look at the guide itself. So we'll just talk about it. I'm going to focus on places where I can show you a code example. The code is right here, module 5C code. I have loaded it up on already. My XAMPP, I think, is already running. Let me just check that. Yeah, so I've got this running. And if I go to htdocs here, I already made a December 4th folder. Here it is. This is just, I don't think I'm going to write any code today, not for the security stuff anyway. So there won't be any sample code that I'll post later. All the examples are coming out of the module 5C code right here. Okay. So there's two sections to the guide. The first one is essentially about injection attacks. I'm just going to move this over because when we put this on video, in the bottom right corner, there's going to be a screen with my face in it. So I'm just going to make it a little bit smaller so that we can look at it. So I call section 1 here the danger of user input. And then section 2 is that's about protecting your app and your users from different kinds of attacks, malicious user attacks. Now there's way more on this. There's a security course later where they'll talk more about this. But I just wanted to talk about the stuff that in this introductory course we have looked at and things that we have tagged as best practices and try and give you the security answer for why those things are best practices. So that's the danger of user input. And then there's a section 2, if I scroll down a bit here, on hiding sensitive information. So, number 1 is about avoiding attacks. Number 2 is about keeping sensitive information away from prying eyes. Okay, and the things that we have to do for that. All right, so what I want to start off with is just the general idea of code injection, and I want to show you an HTML code injection. So it says in the guide that this doesn't work on Chrome, and that was true last year, but this hack now works on Chrome again. So Chrome has changed itself so that this hack I'm about to show you actually works. It works for me anyway. It worked this morning on my Chrome. Chrome updates itself silently in the background all the time. You never know. That's why things sometimes that didn't work yesterday will work today and vice versa. So they used to catch this kind of HTML hack and or injection attack and give you a warning about it in the console, but they don't do that anymore. Okay, so we go to hack me, no, actually I can do this like this. So what this does is this is a really simple script. If we just take a look at the script here, so these are not real, apps. They're not meant to be realistic examples. They're just illustrations of, what happens when you don't do things right. So now I never told you about this officially, but I know many of you found it on your own. The most raw way to access get and post parameters is through this, the $_get, and there's also a $_post. It's called a super global. Notice it's similar syntax to $_session. There's a bunch of these, most of them are associative arrays, but there's a bunch of these special variables that Apache creates and makes available to PHP. And they're called super globals because you can use them anywhere inside of functions. You don't have to declare them as globals anywhere. So back before filter input and other better ways of getting user parameters, what filter input does is it goes to this super global array and it accesses it. So what I'm doing here is every time the user sends a get parameter, it gets put into this $_get array. And now some of you who didn't go through, maybe you didn't go through my materials and went online, maybe not some of the people here, but some people in this course and in the other section who, Googled to get answers to how to do things rather than, following the course, ended up putting this kind of stuff in their code. And I tend to hit them pretty hard for it. There are a number of IDEs that will flag this and say with a warning whenever you put it and say, don't do this because it's dangerous. But this is one way to do it. Now, if you, the dead giveaway is if I go into a script and I don't give the required parameter. So this is expecting a parameter called param. Then I get this, an undefined index. So because I did not put a get parameter up here called param, it's telling me line 16. So that's usually the dead giveaway. If I see this in somebody's code, when I deliberately break it by not putting in get parameters, I know that they're not using filter input. So what we want to do is we go param equals, if I go hello like this, it's just printing it on the page. Oh, I didn't need the quotation marks. Okay, so this is a weird example, but we do this kind of thing all the time, right? We get parameters from the user. Maybe we store them in the database, maybe we don't. And then we take those parameters that the user has entered and we essentially echo them back to the user. We put that information on the page eventually, or maybe we store it in a session first and then it ends up on the page. But at some point, the input from the user is being displayed on the page. And what that means is if you, actually, no, not this. If we go into the page source, it means that the browser is receiving an HTTP response with whatever the user gave us pasted into it. And so you can paste stuff in here. If you don't treat this parameter correctly, you can end up pasting in code, HTML code and JavaScript code that the user has entered directly into the page. And so to illustrate that, what I suggest is that you do this. Oh, it's already here because I was testing it this morning. You put a little script like that with a JavaScript command in it. And the command is location.reload, like that. If I do that, I don't know if you saw it, but if you look up here, you can see the page is reloading. It's just as if it triggers as if you clicked the reload button over here. So what I can do is I can put this parameter in here, script/script with location.reload. And here, let's see what happens. And you can see what's happening is, see up here, it's just reloading the page over and over and over again. So what I've done is as a user, I've found a way to embed a JavaScript script tag into the URL, which then gets executed on the page. Now this is pretty benign. It's kind of annoying because it reloads the page, which causes it to reload again and reload again. If you want to see what it looks like in the code, if we go over here where I'm doing a view source, you can see, look, it just gets pasted right in there, which means that when the browser gets there, it's going to execute that script. Okay, so now this is pretty benign, like I said, but if you can find a JavaScript exploit of some kind, Robert's saying it's a bit like a DDoS attack, distributed denial of service. Yeah, kind of, because denial of service attacks they spam a server, usually from from a botnet that they've created through malware. They spam the server with messages and take it down just by overwhelming it. Yeah, this could do something like that, I suppose. But if you can, it's possible you might be able to find a JavaScript exploit that allows you access to sensitive areas of the user's machine. And if you can fool them into clicking on a link that has a parameter embedded in it like this, then you can get them to execute that script. So anyway, so it's pretty bad. It can potentially be pretty bad. And that's why we never do this. And in fact, it's so potentially bad that a lot of organizations will have a rule that we don't want to ever see $_get in your code ever. Now, because it is possible to be more careful with $_get, to check it, make sure it's there, make sure that it's the right type, filter out any bad characters in it that might turn it into code that can be executed. You can do all that stuff, but it's dangerous because if you make a mistake with it, or if you get sloppy or lazy, you can end up putting in a bad use of $_get. So yeah, so what I'm leading up to here, as Michaela was saying, is just use filter input. And if you use the right filter, the problem goes away. So there is there's another version of HackMe here in the code called HackMe Fixed. And you can see right away it's a little bit different. So it says no parameter down here. If I go param equals hello, it'll say hello. And if I put the script tag in there, location.reload, it just appears on the screen. So it's been rendered harmless. And if you do a view page source on this, right click, view page source, this is what's happened. It's replaced any troublesome characters like the greater than, less than signs, the angle brackets, get replaced with a code like this. This is an HTML way. You can put entities in here. So things like there are words you can put in here that relate to particular characters, like ampersand copy semicolon gives you the copyright symbol. But if you put a hashtag code in here, this is an ASCII code in hexadecimal. So this is our Unicode. This is the hexadecimal number that produces that character. So the angle brackets have been replaced, which means that they will just now appear on the page instead of actually becoming something that the browser would interpret as a script. So that's the fix. Make sure that you're using filter input properly. Which filter did I use here, you guys? Anybody know? There's a few different sanitized filters you can use that do different things. Which one did I use? Sanitize special characters, people are saying. Let's have a look. Yeah, sanitize special characters. So you do that whenever you want. If you think there's a chance the user's gonna enter special characters that you want to preserve, like if you're having them input math and stuff like that, you should use that. There's another one, which is filter sanitize string. If I change it to that and reload, it actually strips out HTML tags completely. So over here, it just removes them completely. So that's another way to do it as well. So yeah, sanitize special characters replaces the special characters. Sanitize string strips out anything that looks like a tag. All right, so that is why I always forced you guys to use filter input. Different organizations might have different versions of best practices, but I decided that that's going to be our best practice for this course. And there are IDEs, like I said, that encode that, and that if you put $get or $post, they will flag it and say use filter input instead. Okay. So validate and sanitize. Now, the other thing that this does for you is it's another way to prevent runtime errors. Runtime errors are bad. You don't want them to happen. They're bad for user experience, but they're also bad because you can see these kinds of messages like the one that I just showed you. If an error message or if an app misbehaves, has runtime errors in it, that can be an important source of information for a would-be hacker. So by looking at this, so there are ways, for example, that you can mask your URL and stuff like that to mask whether it's a PHP file or some other kind of file. But when you start to, when you open up yourself up to a situation where the server might be blasting error messages into the code that somebody can see, then you're giving away a lot of information. So you're giving away information about the structure of what you're doing. This might have been loaded from an include statement. So now we know there's a file called utilities.php. We know that it's in PHP because of the file extension. And we can learn stuff about how the app works and about what kinds of issues that it has. And we might be able to exploit those. So we get a lot of information from that. So that's another reason to use filter input, is it tends to make it less likely that we'll see an error like this, because those errors can be handled gracefully. Okay. Right. How are we doing so far? Does that make sense? So that's called an injection attack. It's called a code injection attack, where the user finds a way through the user input to put a piece of code onto your web page that will then get executed. Okay, I want to show you another one, and this is an SQL code injection hack. So if you don't handle your SQL correctly, and again, I got very specific about this too. I said I want you to use PDO, and I want you to put question marks into your strings when you send them to your SQL system, to MySQL. And again, I hit people hard for not doing that. There's a number of different ways to access the database. There's a set of functions called MySQL and MySQLi that you can use. PDO is better because than all those ones that start MySQL, because PDO is actually not dependent on it being a MySQL database. So there are other types of SQL supporting databases, and PDO should be able to handle all of them, whether it's like Oracle or some other kind of database. It should be able to handle it. The MySQL ones are specific to the MySQL database management system, but also especially the early versions of them, they're just not as safe to use. So anyways, let's take a look at an SQL injection hack. So for this to work, you have to have, let me show you, over in PHPMyAdmin here, in my Scott database, I have a table called new test table, which in order to see this work, you guys would have to import. So if you go into the SQL injection folder here, the code is here for it. You'll have to change connect to be your database name. And you can import new test table, which gives you this new test table. It's just there's nothing to it. It's just a primary key, some names and some ages. Okay, that's all it's stored in there. And then there are these, there's an index and these two delete examples. So let's go to, if I just go into SQL injection, it should load index.html. Let's inspect it. Elements, that's where I want to be. Okay, so you can see it's a form that's going to send a post parameter to delete.php. Now, we often are going to give the user the option to delete something, whenever they're using managing their data. If we give them a button to remove an item from their cart, essentially that's going to become a delete query in SQL at some point. So we're going to have to send an ID of some kind, which we usually code directly into the code. This is just me doing this for example purposes. So we would never do this in a real app where we just tell the user enter an ID. Normally we wouldn't want to show the user anything to do with database IDs. If our app's working correctly, the user shouldn't even be aware that there's a database back there. It should be just like magic to them. They don't know what's going on. They just know that it magically works. But at some point, if you're going to delete something, you're going to have to send a request to a PHP program. You're going to have to include the ID or other identifying information in parameters, and all of that stuff can be hacked and mimicked by a hacker. So they can forge a request that has the correct parameters in it. I'm just making it easy for me to show you the example here. So here's the example. Oh, and maybe it's going to go to delete.php, and I think I better show you delete.php here. It's using PDO, but here's the no-no. It's pasting, and it's using filter input as well. But it's pasting what the user entered directly into the ID, directly into the command. So normally what I've told you guys to do is put a question mark there, and then when you go to execute, fill in that question mark with the value. But this is pasted directly in. Somebody just asked me privately, is that a Sinclair ZX80 behind you? Yeah, it is. I'm surprised that you recognize it. So yeah, my backdrop today is the first computer that I ever programmed. So when I was 11 years old, my dad, who was an electronic engineer, brought home this thing. It was like one of the first, probably the first personal computer for the home. And yeah, that's what I first programmed on at age 11, print statements in BASIC. Back then, all home computers had BASIC installed as part of the operating system. So you were in a BASIC interpreter the minute you got in there, and you could write programs, and we had to save them to tape. It had 1 kilobyte of RAM, 1,024 bytes of RAM. which was enough for like 30 lines of code or something like that. But my dad, being the engineer that he was, expanded that to 4K. So we had all kinds of RAM that we could work with. He had a little circuit board hanging out the back. Anyways, yeah, I still have my the old one. I put it in a shadow box on my desk at the college. But enough about that. It's very easy. This has probably happened to you before. Those of us that have been doing this for a while, it's very easy to get us to talk about the bad old days when computers were made of cardboard and powered by elastic bands and stuff like that. And it can get very boring for people who aren't into that. So I try to limit it. But yeah, that was my first computer. I wrote a text-based game on it. Anyways, so where were we? So we're talking about SQL injection attacks. So yeah, they've done this bad thing where I've done this bad thing where I put the ID directly in here. Why is that bad? Because if things go well and it just has a number in it, then this is going to work and everything's going to be fine. But the user now can actually, I'm giving them an opportunity to complete my SQL command. So they can write some more code here, attack it on the end if they figure out that this is what I'm doing, and things could potentially get bad. So let's take a look. Over in localhost here, you can see, let's delete, I don't know, how about Gertrude? Let's delete Gertrude. So just to show that it works, I enter 35 as the ID, and the delete command tells me what ID it received and tells me how many rows it deleted. If I browse over here, we should see Gertrude disappear. So she's no longer there. So here's the hack. User enters 1 or 1. You can see I did this morning just to make sure everything's working. And when I submit that, so the ID received was 1 or 1. Number of rows deleted was 9. So if I browse this, it deleted the whole table. So that's not good. So how did that work? So since I just pasted in the ID, if when I put 35, this just became where ID equals 35. But when I pasted in, when I put 1 or 1, the entire query becomes this. And what's going on here is, okay, so this is a where clause. Now the way to think about a where clause is, it's going to go through, the way I always think about it is it's going to go through every row in the database and ask, does this row make the where clause true? Is the where clause true for this row? And if it is, it does the action, in this case, deleting. Otherwise, it moves on to the next one. What I've done here is I've put an or, a logical or in here. So it says ID can equal 1. That can make the query true. Or, and 1 over here is SQL for true. So I'm saying if whatever or true, and because of the rules of or, if either side is true, the whole thing is true. Therefore, this is always true. So I've put in a little hack that makes the where clause always true. So I'm basically just going to delete every single row because every single row in that table will make this true. Pretty cool, huh? So it becomes, to the SQL system, it kind of looks like that. Okay, so this is just one example of a way that if you're not treating the data from the user correctly, a malicious user can inject MySQL code and do something bad to your database. A lot of stuff has to go wrong before you get there. You might, if you have an eagle eye, you might have noticed that I'm not really treating the input correctly. If I had made this filter validate int, it would have returned false, and that wouldn't have worked. And if I'd done other things to double check, maybe I could have gotten away with it. But because these kinds of errors are so potentially bad, so I showed you one where you could delete a whole table. There are other types of SQL injections where you might be able to get the page to return to you, to dump out the entire list of users onto the table for you, onto the page for you. So you can actually retrieve information from with the right kind of hack. You guys can look that stuff up if you want. Like I said, a lot of stuff has to go wrong for this to happen, but it's important enough that we try to follow all the best practices to make sure that it doesn't happen. So if we want to make it so that it won't happen again, what we need to do is we change this to delete. I think it's delete fixed. So it's going to go over here now. It's delete safe. And the only difference with delete safe over here is that I do it the correct way. So I put the question mark here, and I have user params, and I pass in the user params. Somebody's asking why does this work? I'll explain it in a second. Let me just I'm going to go re-import this table. So I'm going to delete new test table, and then I will import it again. Choose file, nope. htdocs, December 4th, new test table. And then I'm going to have to move this stuff out of the way so that I can hit go. Okay, so I got my table back. I'm going to go back here, reload this, and just make sure, yeah, now we're going to delete safe. So let's try it again, 1 or 1. Well, first, let's make sure it works. 35, submit. Okay, says it deleted a row. That was Gertrude. Let's see if we deleted Gertrude. Yes, we did. So go back and now try the hack. 1 or 1, submit. Aha, ID received 1 or 1, number of rows deleted 0. And sure enough, the number of rows deleted is 0. Now, why does it work? It's a little bit tricky to explain. I always have a little bit of trouble explaining this. But by doing it this way, what we're doing is, so when we prepare the command, we're essentially compiling it. So we're translating it into sort of the base level code that's going to perform this. So if I put, an ID here, then that gets compiled right in. So if I put 1 or 1 here, that gets compiled right in, and the command is now compiled and fully ready to go. If I put a question mark here, it compiles the command and leaves a slot where the ID is going to go. And then if I fill in the ID later, it's not going to matter if it's 1 or 1 because the command's been compiled. So that's no longer relevant. Now it's just a slot for the ID. So it's been compiled to a lower level language where 1 or 1 doesn't mean anything except it's just that piece of data. So it's the difference between putting the data that the user gave us in as code and then executing that code versus treating the piece of data that the user gave us just as a piece of data. It's almost, you can almost think of it as like this. If I put it in quotation marks, then it's no longer code. Now it's looking for an ID that equals that. Whereas if I don't put it in quotation marks, now it's looking for, now it's become code. Okay, so that's what this does. And preparing ahead of time like this also is also a good thing to do if you're going to use the command over and over again. It makes it a little bit faster, and you can just put in the new ID each time. Okay, so that's my explanation for why this works. It's the difference between treating what the user gave us as code, which is what happens when we paste it directly into here, and treating it as data, which is what happens when we add it in later after the command has already been compiled and prepared. Okay. All right, so really important stuff. And then here's my attempt to explain how parameters help. And there's a final little section here on client-side validation. And it's important to validate and sanitize on the client side and on the server side. And what I'm just making a point here about it, because sometimes when people who are new to web development get into this, they get excited about, you can use the required attribute, you can set the type, you can use min and max parameters, you can constrain the user quite a bit so that they can't enter things into your form that you wouldn't want them to enter. Like if I had created this form correctly over here, if it was type equals number, the user wouldn't have been able to do this and wouldn't have been able to submit that. And so you might think that if you set up this form correctly so that you've done all your client-side validation and you're not allowing submissions, you might think that you're safe, but you're not. I mean, and it's easy to see that just by opening up the developer tools over here. If this was type equals number, I could change it to type equals text and vice versa. So just by now it's a number, now it's text again. So, a clever user can easily defeat all of the security that you put into your form. Furthermore, when the server receives the request, the server really has no way of knowing where the request came from. So another thing that a person can do is forge their own request in various ways and send that off to your server. Sometimes they can even mimic where it came from. So there's really no guarantee when the request arrives at your server. There's no guarantee about where it came from, about whether the user went through your form or not. So there really is no choice. As tedious as it is, you have to check every single parameter on the server side, even if you've checked them all in the form on the client side. It's just not enough. You should still do client-side validation though, because it makes the client's experience much better, and it also saves bandwidth and resources. So if you allow the user to enter bad data on the form, then you'll get bad data at the server, and you'll spend time in transmission of that bad data. You'll waste bandwidth on that. You'll spend resources, memory and processing resources, preparing a response to tell the user that they made a mistake. And stuff like that. So if you can prevent the user from entering bad data in the first place, then it saves you all those resources. And if it's a high traffic app, that's going to be important. Those little resources are going to be important to preserve. But it doesn't make you safe. You still have to check on the client side. Mikhail is asking, is it possible to encrypt the password sent to the server so a hacker cannot intercept it? Yes. We're going to get to that in the second part. We'll talk about where we talk about hiding information. Yeah, we can encrypt it. HTTPS. That's right, Robert. That's the solution. The current solution to that is to use the encrypted protocol. But we'll talk about that in the next part. Okay. So any questions? Shane's saying we should add salt. You're talking about hashing there. So we will talk about that as well in the next, that's right, it's for storage. So we're going to talk about all those issues in the next section. Encrypting, hiding passwords and other information, and also, so hiding them in transmission, hiding them on the client, and also hiding them on the server when you put them in the database and stuff like that. So we're going to look at all of those issues in the next section. Any questions about the injection part? So again, this section was called the danger of user input. And really this is about injection attacks and making your code and your app and your user data safe from injection attacks. The next section is about keeping your user data away from prying eyes. And we're going to talk about that. There's three sections: on the device, on the client, on the server, and in transmission between the client and the server. And all those places you have to worry about not exposing passwords and not exposing credit card numbers and stuff like that. Okay, so it's kind of break time. So any last minute questions about the injection attacks part? Okay, so let me stop my share here. So I'm going to pause the recording now, and I'm going to go make a cup of tea for myself, and I suggest you guys do something similar for yourselves. And then when we come back, we'll talk about the second part of security. And we can talk about the project deliverables for security and for jQuery as well. And if we have time, we might be able to look at some jQuery too. Okay. Okay, so I'm going to pause. Okay, we are back, we're going to talk about the second part of the handout. Here it is, which discusses hiding sensitive information. Okay, so this is the second sort of big security topic. This is about a whole number of things that happen in the whole life cycle of a web page. So for example, let's just talk about passwords. You get the user to log in. You want them to be able to enter their password in a way that is safe, in the sense that somebody spying on them, looking over their shoulder, isn't going to be able to see it. So you want them to not, you want to mask the password, to hide it while the user's entering it. When you transmit the password, you also want to hide it. You don't want it to show up in the URL where somebody looking over your shoulder again could read it, and you don't want it to be visible to a hacker or to somebody who's got like a sniffer on a one of the computers in between your computer and where it's going to. You don't want it to be visible to anybody who might intercept the message. And then when it gets to the server and you store the password and check it, you don't even really want to make it visible to employees of your organization. Okay, there's, for passwords in particular, it's a bit different for credit cards and other things, but passwords in particular, there is no reason that anybody other than the person entering the password should ever see the password. So we're going to look at ways to, and you might be thinking, if you haven't, read about or thought about these issues before, well, if nobody can see it on the server, how can we even tell whether the user's logging in properly? How can we tell whether their password matches the one that we have on the server? So there's ways to do that. So there's kind of, a bunch of clever techniques here that allow us to allow people to keep their passwords completely to themselves. So that's what we're going to talk about. So hiding information on the device. So let me show you. This is an example from Amazon, but it's an old Amazon. I'm going to go Control-Shift-N here to open an incognito tab. The reason I'm doing that is because I want to go log into Amazon and I don't want it to remember me. So I don't want it to, I'm probably already logged into Amazon. So I go to amazon.ca and I go sign in. And I have to put in an email address, me@me.com, continue. And then it asks me for a password. And so as I type it, you can see that it's being masked. And you guys already know about this, but I just wanted to show you, I guess, that even on like the fanciest and most expensive websites in the world, it still comes down to input type equals password. If you want to see that, you can change it to text, and there it is. So type equals password is just a text box where they mask the actual characters. They don't mask the length of the password, though. You can write JavaScript that intervenes to do that, but it's tricky. And as you guys know, a lot of sites these days, especially if they recognize you're on mobile, will give you a button to view the password so that you can kind of see what you've typed. That's purely due to the advent of mobile devices where you can never really quite be sure exactly what you typed because of the whole thumb typing thing in the keyboard. So if you want to put a button in there that will allow the user to view the password, that's an easy way to do it, is just change in JavaScript, just change the type of the input box from password to text. Okay, so passwords should always be masked like that. Type equals password is the easiest way to do it. Where are we? Sorry, where was I? Oh, yes. So yeah, let me get rid of that. Credit card numbers are a little bit different. You do need to, unfortunately, store them in the database in raw unencrypted form. When users are entering credit cards, you really can't mask them because, they should be masked, but you can't because people won't be able to enter them. It'll be a super frustrating experience for the user. So we just have to kind of make a compromise there. People aren't going to remember their credit card numbers, and it's a very long number and it'll be hard to check. So but when you echo them back to the user, you can do something like this. Your payment method, you tell them, credit card ending in 3516. That's nowhere near enough information for somebody to steal their credit card number, but it lets them verify that it's the credit card that they wanted. So some stuff to think about. Okay, so masking it on the device using type equals password, also using post parameters. Okay, if you don't use post parameters, so this is me faking an Amazon request. This isn't real. If they didn't use post parameters, then you would see email equals that and password equals, and of course it would be raw and unencrypted here. And you can verify that yourself if you want. Create a little form with a password in it with method equals get, and you will see the password that the user typed right here in the URL. So you don't want that either. So again, that can be viewed over the user's shoulder. It can be bookmarked, copied and pasted, and so on. So that's why we use post requests for, and this is true of credit card numbers. Anything that might be sensitive information, send it via post. That's one of the main reasons to use post. Okay, so type equals password and post. Then in transmission, this is a little bit beyond the scope of the course, but in transmission, like when I send a password, it's going to get sent as plain text. Okay, so it's like sending an email. You know, when you open up the network tab and you can see the parameters in the network tab there, that means that they are pasted into the message. Even if you use post, they will be in the body section of the HTTP request, and it'll be unencrypted data in that message by default. That's just the way that HTTP works. So that's bad because, you know, with the distributed nature of the internet, I send off a request to Amazon.ca. It doesn't just go directly down a wire from my computer to Amazon. It passes through a number of different servers, including potentially satellites and a bunch of other servers that are on the internet, just passing the message along until it eventually gets to its destination. It's one of the reasons why the internet was developed in the first place. The precursor was called ARPANET, was developed by the Department of Defense in the States. And the idea was to have a network that would survive a nuclear attack. So if you drop a nuclear bomb on a major city, heaven forbid that ever happens. Again, it's happened in the past. Hopefully it will never happen again. If you do that, if you knock out the telephone switches that are there, it can completely knock out any kind of phone transmission. Or if you just bomb a switching office, it'll knock out phone service all over the place. But this new kind of network, ARPANET, it had the ability to reroute itself, to send messages through all kinds of different paths to reach the destination. So taking out a single server doesn't stop the internet from functioning. It's able to route around that dead server. So yeah. So why did I start talking about this? Oh yeah, because the point is that you never know where your message is going to end up between you and the place where it's going to, because of this distributed nature of it. So anybody who's installed a little bit of malware on one of those servers is going to be able to pick up your message, and they'll be able to read your password. So that's why we encrypt it. So we use the HTTPS protocol, Hypertext Transfer Protocol Secure. And what it does is it forces the browser and server to, it does something called public key encryption. So the way this works is it's based on number theory. And when you come down to it, it's based on large prime numbers, factoring numbers into semi-primes is what they're called. So every encryption is based on a semi-prime that's like 300 digits long or 256 digits long or something like that. And if you want to crack it, you're going to have to factor that number into two very large prime numbers with hundreds of digits. And there's just no known way of doing that that's efficient. So there's no known way of doing it that wouldn't take years of processing time on even some of the fastest processors that are out there, generally speaking. So it's really, it's not impossible to crack this encryption that happens between the server and the client, but it's very, very difficult. So for all intents and purposes, impossible for most organizations to do it. So what they do is they exchange their public encryption keys, and the public key you can use to encrypt your message, but then you have to have the private part of the key in order to decrypt it. That's where you have to do that big factoring of a huge number, which is pretty much impossible to do. So as long as nobody has the private encryption key that belongs to Amazon, my messages encrypted with the public encryption key will not be decryptable. And if you want to see an encryption key, let's see. Well, let's look at the my Canvas encryption key. I was just looking at the calendar here. I was realizing I put in your final exam wrong here. It's marked as 4 hours. It's not a 4-hour exam. I'm going to have to double check that. But so you can tell that this is a safe site, or that this is an encrypted site by the little padlock over here. And if I click it, I can say I want to see the certificate. So what you have to have is, to do this, you have to have what's called a certificate, a security certificate, that includes a bunch of information about the organization, the MyCanvas organization, and can be, this is a whole area of cryptography that we can't get into, but it can't be faked. So when the messages come back to us, they have this certificate attached. And if the information in the certificate doesn't match what the sender information, then it'll get flagged up here. But what you can see in here is, you can see, if you go into details, you can look at the public key. So this is what the public encryption key of MyCanvas looks like. These are hexadecimal bytes, basically, 3082010A. This is the public encryption key of the site. And this, so whenever the browser sends a message, it encrypts it using this public encryption key, and then it gets decrypted on the other end using a private key, and vice versa. So when you first come to the site using HTTPS, the two websites shake hands. Your browser has a public encryption key as well that it exchanges with the server, and then the server can send encrypted messages to us, to me, the client, which get decrypted and displayed here. And this is the only way to keep things safe in transmission. Making it a post parameter does not give you secure transmission. It means that it won't be seen in the URL, but it can still be seen en route. If you want to keep it safe, you have to encrypt it, which usually means paying money to a certificate provider to get you a security certificate that is made by a trusted organization that'll be respected by the browsers, and generating a public and private key from that. That's only part of it, though. Yeah, there are. That's right, Caleb. There are free certificates out there that you can get as well, so you don't have to pay. Losing my train of thought here. That's not the end of it, though. Once you've got the certificate, so if you have your own website, if you get a public, a cheap web browsing service, web hosting service, they'll give you the site will support both the HTTP and the HTTPS protocol. CS Unix is a bit weird in that it only supports the HTTPS protocol, which is unfortunate because it means we can't test what I'm about to show you on CS Unix, but you could test it if you had your own site. And I do recommend that, actually. It's not a bad idea to spend a few bucks a month if you have it, to get just a little piece of space somewhere with a PHP on it, and you can upload your projects there and you can play around with it. It'll be a little sandbox for you. So you can try out some of these things. But if you go to, there's a little website called example.com. And it contains, so here it is, it's just an example domain. So somebody maintains this just for teaching like this. So if I want to go to if I want an example web address, I can use it, it's safe. And you can see it's marked as not secure because I went in with the HTTP protocol. If I go in with the HTTPS protocol like this, then now it's secure. Same domain, but using the secure protocol. I'm going to go into the incognito browser again because I want to show you something. So what you need to do is, because in most cases, the user will be able to come in with HTTP or HTTPS, you want to force them, you want to redirect them to use the HTTPS version of your site. You don't want them entering passwords with HTTP. So if we take a look at, Google's a good example. I'm just going to go to Google I'll use .com because I know how that one works. .ca is probably the same. If you just type it like this, by default, at least right now, it's going to send using the HTTP protocol. I've gone into incognito here again, so my browser doesn't remember my history, because there's a redirect that happens. And if I've done it before, so on my other browser, on my regular browser, it may just remember that and we won't get to see the redirect. But here, everything's fresh. So here's what happens. I load google.com. Over in the network tab here, you can see a ton of stuff going on. But here's what I wanted you to look at. Let me move this over here. So the first request, this is the first request I sent, went to google.com, HTTP. This is the URL that I sent. And you see the status code came back. Now, you guys have seen some of these codes before. 404 means not found. 200 means you're good to go. Then there are these 300 codes, which are all redirects, and there's different kinds of them, but they all have the same basic idea, which is it's the server responding and saying, I don't want you to use this address. I'm going to send you to a different address. So 301 has the extra information moved permanently. And then in the response, there's a location given. So the first thing it's doing is it's saying, I don't want google.com. I want to redirect you to www.google.com. So that's just a technical little thing that it needs to do. So first thing it does is there's redirect rules here that tell the browser to reload using this URL. So that's what the next one is. It's the browser reloading using this URL. And then we get a new redirect code, a 302 redirect, which means, I guess it means I did find this resource for you, but I still want to redirect you. And you can see the new location it's giving is an HTTPS location with a get parameter in there, which tells you something about the type of encryption that it's using. And then finally, so the browser receives this response and says, oh, okay, you want to redirect me again, and then launches a new request to this URL that it asked me to use. And now the status code is 200. Everything's good to go. And then the rest of these things are other resources like JavaScript files and CSS files and so on that are being loaded. And we should see, if we click on these, they're all using HTTPS from this point on because they're all relative links. So they're based off of where the original place where we came in, which is HTTPS. Okay, so that's something that you have to do if you want to keep your users safe, because you want to protect your silly users who will come in using HTTP, not knowing that they need to use HTTPS to protect themselves. By the way, I always, whenever I'm asked to enter a password, especially on a new site, or asked to register, I always glance up here, because I swear to God, it happens once every couple of months. I will go on to a new resource, maybe a tool that's fairly new that I want to use, and I'll see not secure up here. And then you have a decision to make. Am I going to register on this site and use a password? If so, maybe make sure it's a burner password, one that you wouldn't use for other sites, or else you will get pwned, as they say. You will eventually get hacked, and somebody will find your password and then use it to log into your other sites. So that's the redirect. And like I said, unfortunately, because of the way the CS Unix is set up, we can't test this. But here's an example. There's lots of ways to redirect. Here's an example of what you can put in a .htaccess file in the public HTML folder. So if you're on Apache, this works on Apache, which is the XAMPP and CS Unix file. You can put a special file whose name starts with a .htaccess. You put it in the root folder of your website, public HTML, and there's a bunch of commands you can put in there. I copied these pretty much directly from one of my own websites that's out there in the world. This is one way to do it. There's a number of ways to do it. We use what's called the rewrite engine, and the rewrite condition is saying if off means we didn't see this, we didn't find HTTPS, so we're going to rewrite. And this is what the new rule looks like. It's going to be an HTTPS link. We're going to put the host name here, and then the request path here. And we're going to send this. I used a 301 code when I did it. Google was using a 302 code for this. Maybe that's correct. I don't know. But any 300 code is a redirect code, and that will prompt the browser to. So you send this request back. The server does it for you automatically. Doesn't go to your resource. And then tells the browser, if you want this thing, you have to try again using HTTPS, and the browser will do that automatically for you. Okay, like I said, there's other ways that you can do these redirects as well, but most of them most servers will allow you to do it on the server level, so it never gets to your file. Yeah, Caleb Pride is saying, yeah, oh yeah, he's saying Cloudflare offers free certificates. But yeah, I was going to mention that, but it hardly happens anymore. But I recently, what site was it? Oh, it was SOCAN. I have an account on SOCAN.ca, which is the organization for songwriters, because I have a couple songs out there. So I was trying to get access to my account. And I was looking back into my old email to see if I could find some information. I couldn't even remember my username, and I found an email where I had asked them. I clicked the forgot my password button, and they sent me my password in an email. There's so much wrong with that, and that's what Caleb's saying in a private message here. Is when you see that, it's time to change your, your passwords everywhere. So yeah, really, really bad. That means that they are they're sending it via email, which is not by default encrypted, so may well be unencrypted at various stages of its transmission. So somebody could easily intercept that and get it. But also, if they're sending you your password, that means they're storing your password on their server, which is also a no-no. And we're going to take a look at that in a sec. That's actually the next section, hiding information on the server. So in the first part of this, hiding on the client, there's some things that you have to do. Like you have to use type equals password. You have to use post parameters. These are things that you guys can do. The second section, hiding in transmission. It's about getting HTTPS, which is a whole process, and often you have to get the server admin to set it up for you, but it's worthwhile doing it. Most of the websites, if you're ever looking for web space, one thing to look for in the list of things they'll give you for like $30 a year or $5 a month or whatever, look for free SSL certificate. That you want that. And then they won't give it to you by default. So once your account is set up, you'll have to do a help desk request, an IT service request saying, I want my free SSL certificate. And hopefully they'll put it together in a way that it renews automatically every year. Otherwise you'll have to keep bugging them for that. It's a constant headache if you're using cheap web servers like I do. But it's just a little tip there. If you're getting a website, look for a free SSL certificate and then get them to install it. Okay. But again, there's not much, and all I can do is tell you what you have to do, because we can't even test this, unfortunately, on CS Unix. One day we'll get ourselves a new server and we'll make sure HTTP is on and we can try these rewrite rules. So there's not really any action items for you guys for your project in there. Although you can always talk about the fact that you're going to put it on CS Unix, so we'll be using HTTPS. And no need for a redirect because there's no HTTP, so you're covered. But then the final part of it is, and there are some action items here, is you need to hide information like passwords on the server as well. And there's a few things to think about here, but you don't really, if you can help it, you don't want people at your company even to be able to go into the database and look at people's passwords. Even if you've vetted them, had them sign security protocols and stuff like that. I mean, if you don't show it if you never show it to them, if there's no way they can see it, then that's much more secure than trusting them. So we try to do that. Now, there's a few things that we have to think about for hiding info on the server before we get to that. And one is your server password should be strong. And what I'm showing you here is, if you go into phpMyAdmin, I don't think you can do this. You can't do this on CS Unix because we don't have the right permissions. We only have one database. But if I go home here and to user accounts, and what can we do? We can go edit privileges on one of them and then change password. So we don't go through any of this stuff in the course because you don't have access to it on CS Unix, and it's a bit beyond. It's a bit more. This is more system administration than actual programming. But what I wanted to show you is there's a little password generator here. So that's what we mean by a strong password. No one's ever going to guess that, right? You click this a few times and you'll get different passwords. The downside to having a password like that is that you're going to need to write it down somewhere, and you'd be surprised the number of systems that get compromised just by things like that. People putting them on sticky notes, putting them in their desk drawer, putting them on their phone in an unencrypted place, and so on. So it's always a bit of a trade-off between getting a strong password and getting one that you're going to remember, because you don't want to ever have to write it down. But in any case, that's if you really want a super strong password, that's where you get one from, is from a password generator like that. This is something that I wanted to highlight before we get to the database part. And this is an action item for you guys. When you're logging people in and creating a session, never, ever, ever store their passwords or credit card numbers in the session object. And let me show you why. So let's go to, I think I need an incognito browser for this, but let's go back to last week's class, which I think was November 27th, when we were looking at sessions. And if we go into the one-page quiz here, if you remember what this does is it immediately creates a session and stores a number in it. So if I'm just going to copy this address, and then I'm going to go into, Caleb says, get your database password tattooed. Yep. Of course, you're setting yourself up for potential kidnappings and other forms of physical violence. If somebody finds out that you've tattooed your password on you, if it's important enough. Okay, so here it is. I'm going to this page. Now what I wanted to show you here is sessions are not just kept in memory on the server, they're kept in a file. And on Apache, if you go into just the XAMPP folder here, you can change where it puts things, but it puts the sessions not inside of public HTML. Most servers won't put them in public HTML where they would be accessible. They'll put them outside of that. So you could never get to this from a web browser, but they're in here, they're in the temp folder. I think these are organized by date modified. So the most recent sessions that there are at the top. But let me just show you, when I go to this page now, you should see it when I hit go, it'll create a new session for me, and you should see a new session pop up here. There it is. So this, if you remember this program from last week, it does a session start, and then it generates a random number and stores it in the session. And if I open this, which I can do with Notepad, there it is. So I stored a session variable called correct answer, and this is saying it's an integer, and the value is 67. So any session variables that you store in the session get put in a text file, unencrypted, somewhere on your server. And you can change where they get stored as well if you want, but it's there. After the session is destroyed, yeah, it will, I think it will right away remove it from the temporary folder, but right now it's there. And just to prove to you, if I put 67, check, you got it. And if I, no, and it destroyed the session. So there you go. You see it destroyed this. It does a session destroy, which removed it. If I reload now, I will get a new session, and I can look at the number there. And there, oh, one. You got it. Okay, so never, ever, ever put passwords or credit card numbers or anything like that into the session, because they will get put unencrypted in plain text in a file, at least in PHP, on the server somewhere, which means that if your server is vulnerable to attack, if somebody is able to gain access to your server, they'll see it. Also, your developers, people working on your site, if they need to debug things by checking what's in the session this way, if they choose to do that, they may end up seeing user passwords and credit card numbers as well. So never put them in the session. And in fact, Facebook got caught a couple of years ago. Here it is, last year. If you read this, it's still up, I think. Yeah, so January 2019, we found that some user passwords were being stored in a readable format within our internal data storage systems. So that's just put in a generic way for the layperson. But PHP uses, JavaScript uses PHP on the back end. Their whole site, pretty much their whole site is written in PHP. And yeah, I mean, you can verify that, but that's pretty much what happened is somebody was at some point made a decision to put passwords into the sessions, and those sessions were getting flushed to the disk, and somebody discovered that they were available there. So this is an example of Facebook being a good corporate citizen and announcing what they discovered. They don't think that they got hacked. So it says here, nobody outside of Facebook ever found them. Nobody, to their knowledge, nobody gained unauthorized access to the server and got the passwords. Oh yeah, look at that, a new one, Instagram as well, which is owned by Facebook. Wow, why did they not check that in January? Oh my goodness, when they found out that they were doing it in Facebook, why didn't they also check it in Instagram? Whatever. Anyway, so in any case, they don't think that it compromised anybody, but they're just informing us, I guess, for transparency and to build user trust and stuff like that. So yeah, so don't ever put unencrypted stuff in a cookie. Sorry, in a session. Okay. So you shouldn't store plain text for the same reasons. Don't store it in your database. And we're not going to talk about credit card numbers here. We're not going to worry about that, at least not for our purposes. But passwords we can do something about. So when you store a password in the database, there's a special kind of one-way encryption, which is called hashing. Okay, so what this does is you could take a string, and to hash it means you turn it into this unintelligible long string of characters. And once you've gone from the actual, say my password is God, right? That's one of the top 10 passwords that are easy to hack, especially for system administrators. At least back in the day, they used to use God as a password because they're the God of the system. So you take the string God and it becomes this weird long encrypted string, which doesn't resemble the original. And the thing that makes it one way is that there's no function that lets you go back. So it's a one-to-many function. So it maps, it's a many-to-one function. So it maps many different strings to that hash. And there's no easy way to go backwards from the hash. There are ways around hashing. So what you can do is you can create what's called a rainbow table, where you take like every word in the dictionary and compute its hash. And then if you gain access to a database that contains hashed passwords, you can look it up in the rainbow table. And if you're lucky, somebody will have the word watermelon as their password and you'll have a hash for it. And you'll know that that user's password is watermelon. So that's one of the main reasons why we don't use watermelon as a password. We include symbols and numbers and so on to make them really unique so that rainbow table attacks aren't going to work. In any case, so it's a one-way function. There's no way to get back. So what you do is when they register, you send the password to the database. You don't store the password, you store the hash. You hash it and store the hash. And then when they go to log in, you again receive the password they're trying to log in with. You hash it and then compare that hash to the one that's stored. And if it matches, then you let them in. So you never, you do receive, your code does receive the password. Hopefully you've used POST and you've used HTTPS, so it was encrypted on the way to your server. The first thing it does with it is hash it. It doesn't keep it. It hashes it and then either stores it in the database if they're registering or compares it to the hashed version from the database. And this is really easy to do in PHP. There's a function called password hash, which takes the original password the user gave you and hashes it for you. And there are a number of different encryption algorithms, hashing algorithms for doing this. If we use password and you specify which one you're going to use by a constant here. So I'm going to suggest you guys just use password default, which will be the best available one right now. So they hash it and it encodes a long string. Do I take apart the string? No, I don't. So let me show you, I have some code for you here that shows this working. Here we are. So we're back in December 4th, like that. Okay, hashing. So there's a little thing here where I can type in something. So I'm going to type in the word hello, okay, and hit submit. And it says hello does not match this hash. So this is what it's done. What this program does, this hashing.php program. Now, normally you would get the hash out of the database, but what this program does is it doesn't do that. It just generates a hard-coded password hash to demonstrate how it works. Let's go in here. So what I've done is, so normally in this step here, you would look up the user ID and retrieve the hashed password. Oh, why am I using bcrypt here? I should be using default. Like that. I think is that going to be the same one? Let's have a look here. Oh yeah, that changed the string slightly. I don't know if you noticed that. Slightly changed the string. So I don't know, I encoded that wrong. You can put different values here, but password default is your best bet. So what I've done is I've just created the hash that I want to compare to by putting my password in there. So if I want the hash to match, what I need to do over here is type in my password like that. Here, wait. Let me change this to text so that you guys can see it. So I type in my password, submit, and it's going to let me in because it does match the hash. Oh, I think I did this. Add that to it. So again, this is the hash here. So there's two functions for this. So when the user first registers, you use this function to create a hash of their password, and you store that in the database. Don't store their original password in the database, store this, and don't store it in the session either. And then when they go to log in, so you get the password that they entered when they tried to log in, and you get their user ID that they entered. And then you retrieve, using the user ID, you retrieve their password from the database. And then you call this special function called password verify, where you put in here what they entered and then the hash. and it tells you whether that password matches that hash or not. And there's a bunch of stuff in here. The first few characters of this hash with the $ here are the encryption algorithm that was used. So this is telling the system what the algorithm was. This is telling the system, I think this $10 tells the system the length of the salt. I'll tell you what that means in a second. And then after this $, I think the next 10 characters are the salt. So in addition to hashing your password, it also salts your password, meaning that it adds a few characters onto the end, again, to make it less accessible to a rainbow table attack. So if I type my password, it actually hashes, my password 08VOOHOJ and does that hash. So that when it's trying to do the comparison, it hashes, it first adds this stuff, the salt, to the hash, and then it hashes it to see if the remaining part, which I think is from here, this part actually matches. So there's a lot in the string here. But the take-home message here is that we are going to hash and salt our passwords, and it's very easy to do. We hash them like this for storage, and then we verify like this. We retrieve the hash from storage and verify by calling password verify. Okay, a question from Caleb. Caleb's asking, if you use password default, could it break it in the future if they change the algorithm? I think you may have asked that before I talked about what's in the hash. The answer is no, because when it does password verify, it reads the first few characters to find out which algorithm you used, and then it applies that algorithm to the rest. So it's quite clever. It's the hash string that it generates is not just the hash, it also encodes which encryption algorithm was used to do the hash in the first place. So no matter how or when you hashed this password, even if you hashed it 20 years ago using whatever was the best method at the time, it's still going to be able to, password verify will still be able to rehash this password and check it against the stored one. Okay. Any questions about that? So that's definitely on the to-do list for you guys. You may have already written the login system, which uses plain text passwords. At some point you should, if you've done that already, you should modify it so that you're logging in using hashed passwords. And that's it. So the quick reference is very small. There's only, the code that I gave you is only 2 lines of code, but using it is important. And then the rest of it is just some advice. Always validate on both sides. Always use SQL command string parameters for sensitive information. Always mask, use post, encrypt, and encrypt for storage. Use hashing and salting to store passwords, and never store passwords or other sensitive info in the session object. Okay, any questions? So you guys have a couple of deliverables that are due for Monday. The first one is the security audit. So what I want you to do here is it says assess your app for security issues using the code you've written so far and the plan for the app that you submitted a few weeks ago. So hopefully you have some code that you can review, but if you haven't done any work on it yet on the code, then you'll just have to rely on the plan, right? So what would you add to your plan or to your code to make it secure? So 2 sections in the report: code security and data security. Is your code safe? Are you protected from runtime and logic errors caused by user input? And what steps have you taken? What steps will you take to make it safe? Okay, so be as specific as possible. List the things that you're going to do to keep your code safe from injection attacks. And then under data security, what are you going to do to keep the user's information secure on their devices in transmission and on your server? Okay, so what steps are you taking to minimize the risk that an attacker might be able to access your data? Okay, so it can be really quite a short report. It can be less than a page for sure, like half a page even. As long as just make sure you're getting all that information in there, make sure that you're using correct terminology and so on. And yeah, there are a few best practices that I'm expecting. Okay, so even if you don't write this in the security audit, I am going to check for filter input, PDO, SQL query parameters, password hiding, including using hashing, and credentials checking. So credentials checking is checking for login on every page and every AJAX request. So that means you're using session management to make sure that somebody who's not logged in can't access those files. Okay, so that's important. Whatever you end up writing here, so yeah, because the rule is you actually only have to highlight 2 specific steps in each area. So that's what makes it quite a short report. You don't have to talk about everything you're going to do, just talk about 2 things in each area. But whatever you talk about, I still do expect you to actually implement a lot of the stuff that we talked about in this course, in this class. Okay, any questions? Now, if you haven't already, you should go take a look at the jQuery stuff, which is just a couple of quick videos. There is this other jQuery plan. You could probably fit both these plans on the same sheet of paper, although I'm expecting you to hand them in separately. So it's just some ideas for how you can involve jQuery. It makes it really easy to do animations and effects. Makes it easy to do DOM manipulation and event handling. You can do AJAX as well. You'll have to research that. And the plan is just a one-page document. Highlight, again, at least 2 ways in which you plan to use jQuery in your project. Okay, so you'll have 2 subsections, 2 sections, a title that captures the use of jQuery, right? Like I will use jQuery for AJAX, and then a description and the advantage of using jQuery for that task. And I also want a specific code example. And it doesn't necessarily have to be from your project, but it could be. I want you to show, so if you're going to do AJAX, I would want to see an example fetch command on the left and an example jQuery equivalent on the right. If you're going to do a basic DOM manipulation, like changing inner HTML, show me the raw JavaScript on the left and the jQuery way on the right. Okay. So again, it's like a lot of people, like I said, when I do this in a live class, finish it in 15 minutes in class. So it's not a big deal. It's worth 1% total of the whole year. Okay, 1 mark out of the 20 of the projects for both of these things. I don't know. Now somebody's asking me, Michaela's saying, when will assignment 4 be graded? My aim is to get to it soon. I apologize, but it's just with all my courses. And I guess also they've increased the enrollments this year. So I have a lot more students in each class than I normally do. And it's just gotten away from me a little bit. So I prioritized your project plans so that I could give you feedback on those because I thought that was important. I will grade assignment 4 soon. I will probably not grade the security and jQuery ones right away. I'll probably do assignment 4 first. So I might be able to get that started this weekend. I'm hoping by the first couple of days of next week, I'll have that stuff graded for you. Okay. I know it's taking a little longer on some of these things than it has in the past. It's just that there's more piled up at this point. Any other questions? How are you guys all feeling about the final project? Feeling like it's doable? Keep in mind, the timelines are a little bit compressed on the project. But just keep in mind what I wrote about the scope of the project in the original project handout. It's not, even though it has the title project, it's really not that much bigger than an assignment. It's maybe a double assignment. So it's not your life's work. And it's okay to just hit the minimum requirements on this. I know a lot of you have some really ambitious plans, which is awesome. And a lot of you, I think, are thinking about turning this into like a portfolio item, which is great. Just keep in mind, you don't have to, even if that's your plan, it doesn't all have to be done for this course. As much as you might like to show me your awesome final completed version, the version you hand in can just be a working one or two pieces of the final project. And if you want to show it to me, if you keep working on it over the break and next semester, and you want to show me the final product, I'd be happy to take a look at it as well. But don't feel like you have to hand in everything with all the bells and whistles for credit in the course. You just need to do the minimum. Okay. So there's 20 people out there. Everybody's kind of quiet. I think maybe that's it for today. All right, so I'm going to post this later, and I'll probably post a note about it as well. And I'm going to fix the final exam date and time went in the calendar wrong, I think. So I'm going to fix that or make sure it's correct. And I'll post an announcement about that as well. Other than that, I will say have a good weekend. Bye, guys. If you want to say goodbye, now would be a good time. Thanks.
Goodbye. Have a good weekend.
Thanks, Isabel. Sanjay, Yorga, Robert, Shane too. All right. Have a good one, you guys. See you next week.